Okay, welcome to my talk. I would like to introduce to you within the next around 20 minutes the OpenWebGlobe SDK. It's a software development kit for creating your own virtual globe application, and of course it's based on WebGL and HTML5. Now, maybe for the introduction, we work at this project for about a year. We started in April 2011, and it's a project. I work on it. Martin also work on this. It's a project from our institute, from our university here. So what's the OpenWebGlobe SDK? I already said it. It's an open source software development kit. It's based on WebGL and HTML5, and it helps you to create your own application. Due to using WebGL, it runs plugin free in most of the browsers. And it's intended to use large-scale imagery or elevation data or some kinds of other geospatial data. What I'm talking about, you already seen in these two screenshots. It's out of a project we made together with the Swiss Federal Office of Topography, Swiss Topo. And you see, this is the first application we did. We had at the left, you see the virtual globe application. And at the left, you see the globe. And at the right, you see we display there high resolution image and elevation data. So I want to show a short movie here so that you can get an impression on what I'm talking about. You see we are in Switzerland now here. This application allows you to fly virtually through Switzerland. You see also we have tiled data, so the data is loaded in different resolutions. As near you get, you will see this. We also support 3D models. We will see later on. And we also support different navigation modes. And this was the result of this project. It's already online, so if you want to try for yourself, you can go to swiss3d.openwebglobe.org. Later on another slide I will show the URL again. So here you see the textured 3D models insert into the globe. We also support other objects. Okay, now the OpenWebGlobe SDK consists not only of the viewer part, of the WebGL part, it also consists of a data processing part. So the whole SDK is split up into two parts. The viewer part we already have seen, but the other parts I will explain you later. First of all, I would like to talk a little bit about this viewer part. And the viewer part consists mainly out of a JavaScript library you can include in your HTML application, in your HTML file, and it helps you to create a virtual globe. It provides some functionality for the integration of your own contents, of your own 3D models. It provides functions for navigation controls and also for coordinate measurements and so on. I would like to show some examples of content we're supporting. At the right you see elevation and imagery data combined on the top screenshot. If you haven't any own data, any owned image data, you can also use public data. So on the lower screenshot you see OpenStreetMap data, which is public, and you can also use this for your virtual globe application. You can also define different point of interest. If something is interested, you can add a POI in your own style with different icons, different text style, whatever you want. And POIs and all other objects are arranged in layers. So you have defined a layer first, and then you can add some points to these layers. And there is also some other functionality for these layers, like you can show or hide these layers, you can load them or destroy them during runtime, and so on. The same is with textured or untextured 3D models. You can load them in, display them, hide or show them, and so on. Another feature is that you can use this HTML5 canvas element in the 2D version. So you can draw something on a HTML5 canvas, and then you can load it into the WebGlobe application as a billboard. So this screenshot is out of a bachelor thesis we had at this institute, and now here you see statistical data which is painted on this Canvas 2D a diagram, and then it's loaded into the OpenWebGlobe. So this allows you to integrate dynamic content into the application. We also support image overlays and vector overlays. I don't want to show this. Maybe it's worth to mention we always also support point cloud data. So this is maybe interesting for the geo community. If you have a point cloud, which is acquired maybe by a laser scanner, you can easily add it and show it in OpenWebGlobe. So this was also a feature which came out of a project we did with our technology here. We also support real-time position data. We had another project we implemented that. We got the position data by using a WebSocket, and so there was a POI. First there was a simple POI, and you could follow the POI in the application. Now let's look at the code. I learned this morning that the number of lines in code is a very important measurement. I don't know how many lines these are, but there are just a few lines, and with these few lines you have already a working virtual globe in your browser or in your application. So all you have to do, I hope you're a bit familiar with that. All you have to do is to create a main function, and then we have a lot of helper function. We have this OG create context from canvas. It's like an initializing function which initializes the whole globe. And then you have the OG create globe function which really creates the globe then. And then all you need to do is to tell to OpenWebGlobe where are the images to download and where is the elevation data and so on. You can do this. I've added here just an image layer. There are blue marble image from the whole world, and you just have to specify the URL, the layer, and the so-called service, and then you have this function OG add image layer, and you tell OpenWebGlobe where to download the images. So I think it's quite easy. Now the web viewer architecture, every content is managed in a layer. We have this layer object. It's all object-oriented JavaScript, and for each layer we had the object. So we had a POI layer, so we have also the POI objects and so on. Now the second part of the SDK is the data processing part. We need to pre-process this data because the images and elevation data, they are huge. They are sometimes terabytes of data. So there is a need for this image, for this pre-processing. Now what I mean by this pre-processing is we tile this image data. Imagine you have some image and elevation data. So we have to tile this. We have to calculate different resolutions, maybe another projection system, and then we have to store this in an image pyramid. So in a special spatial structure. So this is a very this task needs high resolution, high performance. So we parallelized the algorithms, and these algorithms are written in C++. If you have tiled this image, you can upload it to a cloud storage or to a web server. Not only the image will be tiled, also the elevation data. We see that later in another screenshot. As soon as you have pre-processed this data, the viewer part of the SDK only requests the currently visible data in the browser. So if you move around through Switzerland, there is a stream of image and elevation data. Yes, I already explained this. This is this calculation into this image parameters. And now you see a screenshot. We also do the same with the elevation data. So you have different resolutions of the terra. And this is also pre-calculated. Now, if you fly through Switzerland, you stream these tiles from the server. And of course, nearer tiles which are near the camera are loaded in a higher resolution, and tiles which are far away are loaded in a much coarser resolution. And of course, only current visible, we do this current visible tiles will loaded. We do so called frustum calling. Okay, the processing tools, I already said this, are open source and available at GitHub. They are written in C++. We support different geo formats like TIFF or ArcGIS. All algorithms are optimized, and they are scalable. So that means you can run the pre-processing part on your own laptop, on a computing cluster, or anywhere in the cloud. Now, what we want to do in future, or what is an idea we have, we would like to process all the data directly in the cloud. So the idea is that you can, if you have raw data, you can upload it to the cloud, and all this processing is then a server-side step. That is what we currently think about it, or maybe work on it, I think. Let's show some showcases. We had this application I already mentioned. It's Swiss 3D. It's together with the Federal Office of Swisscom, and it's kind of a technology showcase for OpenWebGlobe also. So you can zoom in, you can zoom out, you see very high resolution data from Switzerland. There is also a location search service, so you can type in here at the top a city or a little village, and then you will fly to this specific point. We also show this 3D objects, and so. Now the other application we implemented, this is not public accessible, but we had this in the sense of a rapid 3D mapping application. So we implemented for this point cloud support, and also some real-time things like real-time loading of new points into the application, and also this position of different persons were visible within this application. The last showcase I would like to show, we created an interactive game. It's mainly for exhibitions, where you can test your knowledge about geography in Switzerland mainly. And it's quite a nice game, and it's kind of an eye-catcher when you have a stand at an exhibition. This worked, this is also open source, so it's available at GitHub, where you can download it and adapt it to other countries, whatever. If you want to know more about OpenWebGlobe, I recommend you to visit our homepage, openwebglobe.org. There you will find an overview. We publish news there, some tutorials to get started with OpenWebGlobe, a function reference, and so on. We host our code at GitHub. It's all open sourced. We communicate by Twitter. You will find some YouTube videos, and sometimes we use JS Fiddle for the online tutorials. If you want to know more and you're here tomorrow, then I recommend you to attend the workshop. There's a workshop about the OpenWebGlobe. It's kind of a hands-on workshop. So we try to create a simple simple virtual globe application together. Okay, then thank you very much.
Thank you very much, Benny. We have time for questions. I see there are many questions. Let me start here.
How do you see the future of OpenStreetMap? Is there anything like OpenStreetMap for satellite imagery or elevation information similar to OpenStreetMap?
I don't know what they planned at OpenStreetMap if they want to integrate elevation data.
So if we use your WebGlobe, where do we take the satellite imagery from?
At the moment, there are some free satellite images like Landsat or anything else you can download, you can order, and this for our demonstrator we had the satellite imagery from SwissTopper mainly, but there are also free resources in the web.
Okay, next question, thank you.
First, congratulations. I think it's a great work. Then I would like to ask you if you have already checked the performance when rendering 3D objects, and especially the point cloud, coming from, I guess, LiDAR data.
Yes, the performance it's very good. I think we had the point cloud data by 3 million of points, and you have the navigation was quite fluid, so you haven't had any stock-ins and so on. But it depends on your client, of course. As soon you have more points, 15 millions or something, you still can load this data, but then you will get in interruptions and so on. But there's a need, I think, for rich point clouds. There's a need to pre-process and to thin these point clouds a bit out, so to delete redundant points.
And then another second, are you using any level of detail, or have you implemented any level of any LOD object when rendering the 3D objects or even the point clouds? The same as, for example, the DEM, we have seen that there is different resolutions for different distances.
Yes, you already seen it in imagery and elevation that we have these LODs. We planned this to do for point clouds. So we build a voxel space or a voxel cube, and use also a LOD mechanism. We have also planned to do this for 3D models, but until now it's just static. We're working on that. I would say, yeah.
I'm curious to know how data heavy the application is. Let's say that I browse to your demo and launch it. How much data do I need to download?
It depends how long is your flight through Switzerland. So I think around if you're a long time and fly in a high resolution through a valley, for example, diagonal through Switzerland, then I think it's about 100 megabyte or something like that.
Do you use some kind of mesh compression for transmitting?
No, not now.
Okay, there's unfortunately time for one last question.
Hi, my question is how much intelligence do you have after the processing in your server? Is it Is it just like a data storage where your client just requests the tiles? I want this tile, I want that tile in that resolution, or does it all
Yes.
happen in JavaScript, or is there intelligence also on the server side?
There is no intelligence at the server side. So we just request for tiles. The tiles are just files. It's a normal file server, I would say. But it depends what you use. You can also this WMS server. So you can, if you have a special geo server, you can also request for specific tiles, and then you have to code the extent, the coordinates of the tile you want into the URL, and then you need logic on the server. But we don't, in the normal way, you don't need any logic on the server.
Okay, thank you very much again.
Thank you.